Welcome to my YouTube channel. In today's video, we'll talk about one of the most revolutionary inventions of the 21st century, the industrial 3D printer. From aerospace to automotive, from medicine to construction, this single machine is transforming how products are designed and manufactured. 3D printing, also known as additive manufacturing, has moved far beyond simple plastic prototypes. Now it's used to build metal airplane parts, car engines, prosthetic limbs, and even entire houses layer by layer. In this video, we'll explore in complete detail what an industrial 3D printer is, how it's installed and set up, all major parts and their functions, step-by-step working process, maintenance and repair, and finally, why it's such an important. Stay tuned till the end. What is an industrial 3D printer? A 3D printer is a machine that builds objects layer by layer from a digital design file. Unlike traditional machines like lathes or milling tools that cut material away, a 3D printer adds material only where need. In the industrial world, these machines are large, precise, and powerful. They're capable of printing in multiple materials, such as metals, ceramics, carbon fiber, resins, and high-performance plastics. Industrial 3D printers are used by major companies like Boeing, Tesla, GE, and Siemens to create complex parts that are lightweight yet strong. There are different types of industrial 3D printing technologies, including FDM melts and extrudes plastic filament. SLS uses a laser to fuse powdered materials. SLA uses light to solidify liquid reshown. DMLS creates metal parts by fusing powdered metal with a laser. Installing an industrial 3D printer isn't like setting up a small desktop machine. These are complex, heavy, and expensive systems that require precise calibration, proper environment, and skilled technicians. Step-by-step process. Site preparation. Choose a clean, vibration-free environment with proper ventilation and temperature control, 20 to 25 degrees Celsius, 30 to 50% humidity. Power setup. Requires 3-phase power with proper grounding. Unboxing and positioning. Delivered in sections. Use forklifts/cranes. Keep 1 m clearance. Software and connectivity. Install control software and connect via Ethernet/Wi-Fi/USB. Material loading. Load filament/resin/powder. Handle metal powders. Calibration. Level bed. Align nozzles. Calibrate laser path. Safety checks. Test sensors. Emergency stops. Ventilation. After setup, perform a small test print before full production. Frame and gantry. Strong steel/aluminum structure. Build platform. Print bed. Heated/magnetic surface for printing. Extruder or print head. Melts and deposits material. Material feeding system. Feeds filament, resin, or powder. Motion system. Controls X, Y, Z movement with servo motors. Heating and cooling systems. Maintain temperature balance. Control board and sensors. Machine's brain. Laser or UV light source. Solidifies material in SLA/SLS. Filtration and ventilation. Working principle. 3D model design. Created in CAD software. Slicing process. Converts model into thin layers. G-code. Printing phase. Material deposited layer by layer. Cooling and solidification. Controlled cooling/cure. Maintenance, repair and importance. Lubricate rails/bearings every 200 hours. Clean extruder and nozzle after every print. Check belts, pulleys, motors. Replace filters monthly. Update firmware regularly. Reduces material waste up to 90%. Enables on-demand, mold-free production. Lightweight parts for aerospace/EVs. Speeds up prototyping and development. That's the complete overview of an industrial 3D printer, from installation to working, parts, and maintenance. This machine represents the future of manufacturing, where imagination turns directly into reality. Thanks for watching. Like, comment, share, subscribe.